Okay, so possibly the hardest little piece of this is using the law of cosines to handle the angle side-side case. It can be a little bit challenging, but I think we can kind of lay this out fairly well here. So what I did is I set up an angle side-side case. If you watch the earlier videos, I actually stuck with exactly the same problem that I had before. And you can tell that I have some stuff laid out here. So what we always do is look for where things are across from each other. And I guess this was A, this guy was B, and this one was C. So I'm not really sure what C is yet. And so that's kind of how I'm going to set this up. I'm going to start with 11 squared, that's the side opposite, would be equal to the sum of the other two sides squared, that's 8 squared and C squared, minus 2 times 8 times C, this guy right here, times the cosine of the angle where it all began. Now, this is going to look a little bit messy for a moment, but I'm going to go ahead and just do a little bit of simplification. Now, over here, I notice that I have a 2 times 8 times the cosine of 48. It's some kind of ugly looking decimal, so I've got negative 10.706, but I still have this little c sitting right here. Now, the only thing that I have left to do to finish my story is move some things around just a little teeny bit. I'm going to move this 121 to the other side, so 64 minus 121 is negative 57. Now, this should look very much like a quadratic that you have solved in previous classes, but it's kind of weird because we're using the letter C here instead of an X. And so this is kind of weird because X in this case, or C, is the side length. And so the solutions to the quadratic right here are going to be the side length or lengths dictated by C. So you can go and grab the quadratic formula, but I personally made a little program on my calculator to help me do that. And so in the quadratic formula, A again represents the coefficient in front of the squared term. B is the coefficient in front of the B term, and negative 57 would be my last value. And you'll notice it says, okay, your values of C, which is this side right here, are either 14.607 or they're negative 3.901. Well, this right here is not even possible. No, you can't have that. So we do know that we got 14.607 as a valid answer. And now if I wanted to, I could use the law of sines, because I could then say the sine of 48 over 11 equals the sine of C over 14.607. And I could continue this problem and finish it out if I wanted to, but I really just wanted to get off the ground with it. Now, I changed it to this story right here just so you could see. Again, I started with the 11. They're across from each other. 14 plus C, 214C, cosine 48. I've already done the same steps I did above where I squared each piece and then I moved things across so it looks like a simple quadratic. Now, what's going to happen this time is I still have 1, I have negative 18.736, and I have 75. So in this story, I've got the two values of C as 12.94, and the other C, I'll call it C1 and C2, of 5.79. Well, that is not only possible, in fact, that's perfect. So I do have one story right here where it was that, but then that means there's another triangle where instead of swinging to the outside, it actually kind of swung to the inside where its angle was 5.79. And so these are both valid triangles, and I would have to use the law of sines to continue on to solve the missing pieces. And last but not least, here's a problem. We looked at this before where there was no solution, but let's see. So again, I went through the same process. Here is letter C. So I said 11 squared is 35 squared and C squared. This is just our setup. So I'm going to do the quadratic one more time. And let's see what happens, because the law of sines says there's no triangle. So this is going to agree with that. But how does it actually show it? And my calculator just says, ooh, complex roots. These are imaginary. This is crazy. That's going to tell me there's no such triangle. Because if this is a triangle, the triangle has to be real. There can't be imaginary solutions to a real triangle. And so that's showing you the ambiguous case. So hopefully that is helpful. And again, that's That's it. See you. Bye-bye.